Welcome to SciSpectrum Lab Essentials, your source for equipment, instrument, and consumables.
Let me just start by asking you this. How do you really know if a substance is pure? Think about the medicine you take or the materials that make up your phone. How can you be sure it's actually what it claims to be without any unwanted stuff mixed in? It's a huge deal. And the answer, believe it or not, boils down to one single, incredibly precise number.
And that number, of course, is the melting point, the exact temperature where a solid just gives up and becomes a liquid. Now, the key word here is sharp. See, for a really pure substance, this change happens at one very specific temperature. But if you've got impurities in there, that sharp point gets all blurry and melts over a range of temperatures. So a sharp melting point is like a perfect fingerprint for purity.
But okay, how do you actually measure that fingerprint with the kind of certainty that modern science needs? You can't just stick a regular thermometer in there and hope for the best. Nope, you need a specialized tool. You need a digital solution. And here it is. This is the Digital Melting Point Apparatus. This is pretty much the hero of our story today. It's this really sophisticated piece of equipment designed to do one thing and one thing only: measure that exact moment of melting with incredible accuracy. This is the machine that solves that purity puzzle for us. So it definitely looks impressive, but how does it actually work? Let's pop the hood and take a look inside. We're going to break down the anatomy of this amazing piece of tech. Just looking at its key advantages, you can tell it's built for both performance and simplicity. It's super accurate, it's easy to use, and it gives you a crystal clear view of what's happening. But two things on this list really stand out to me: that silicon oil bath and the built-in magnetic stirrer. These two things right here, they're the secret sauce to its precision. And this table shows you exactly why. So think of the silicone oil bath as like a high-tech double boiler. It heats the sample perfectly evenly from all sides, so you don't get any weird hot spots. Meanwhile, that magnetic stirrer is constantly mixing the oil, making absolutely sure the temperature you see on the display is the exact temperature the sample is feeling. Then you add in a high-res camera, and boom, the scientist can watch the whole thing happen in perfect detail.
All right, so we know what the parts do. Now let's actually put this machine to work. I'm going to walk you through how a scientist takes a measurement, and you'll see it's probably a lot more straightforward than you think.
It's really just a simple four-step dance. First, you prepare a tiny bit of the sample in a little glass tube. Then, you pop it inside and start the heating. And now comes the most important part. You just watch. You monitor the sample on the screen, and the very second you see those solid crystals collapse into a liquid, you hit the stop button. And just like that, the machine freezes the temperature on the display, capturing that perfect melting point.
Okay, talk is one thing, but in science, the data is everything. So let's look at the numbers that really prove just how powerful and precise this machine is.
First up, its range. This thing can measure temperatures all the way up to 300 degrees Celsius. That's hot enough to test a massive variety of compounds, everything from common pharmaceuticals to heavy-duty industrial materials. But this is the number that really shows its power: a resolution of 0.1 degrees Celsius. That means it can spot unbelievably tiny differences in temperature. We're not just getting in the right ballpark here. This is pinpoint accuracy, the kind of accuracy that can tell the difference between a pure substance and one with just a trace amount of an impurity. It's incredible. And get this, it does all of this with just a tiny pinch of material, only 4 to 6 millimeters of powder in a tube. Now, when you're working with a brand new compound that's really expensive or hard to make, this kind of efficiency is absolutely vital. You don't waste any of your precious sample. And it's a whole kit, It comes with everything you see here, so it's ready to go right out of the box. But let's move beyond the hardware and the specs. What's the real impact of all this? Let's zoom out and see why this matters in our daily lives. So, we've seen the machine, we've seen the process, we've seen the numbers. But why does this level of detail, this obsession with a fraction of a degree, actually matter in the real world? This quote from the source material really says it all. In the pharmaceutical industry, purity isn't just a nice-to-have, it's a non-negotiable requirement. The difference between a pure, effective medicine and a contaminated, maybe even harmful one, could be a tiny fraction of an impurity, and that's something a precise melting point analysis will catch immediately. And it goes way beyond just medicine. This kind of precision ensures the quality of the plastics in our cars, the chemicals used in our food supply, and the materials in all our electronics. Honestly, every single time you trust a product to be safe and effective, you're relying on quality control, and precise measurements like these are the foundation of that trust. So the next time you see a simple, solid substance, just remember the incredibly complex science that's hidden inside its melting point. It really makes you wonder, doesn't it? What other invisible technologies, what other amazingly precise measurements are working behind the scenes right now, making sure the world around us is safe and reliable? Thanks for tuning in.